Hi, everyone, and welcome. Today's webinar will help you unlock the power of geocells as a value engineering solution for your mine infrastructure. We'll discuss how the GeoWeb 3D soil stabilization system offers a better approach to soil stabilization challenges when accessing sites over soft ground, controlling and containing stormwater, protecting geomembranes in basins, tailings, and heap leach pads, and reclaiming slopes at mine closure. Through 3D confinement and the strengthening of infill, less material is required and on-site waste rock can be beneficially reused. The GeoWeb system offers increased speed of operation, lower maintenance, safer installation, and lower total cost of ownership, helping you meet environmental, social, and governance goals while improving production. I'm JP, the International Business Development Manager for Presto Geosystems. I meet with specifier and contractor clients to secure and support our international network, driving new opportunities with a focus on mining and environmental remediation. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team. Here are the things I hope you get out of today's presentation. Understand the benefits of geocellular confinement for high-performing, long-lasting mine infrastructure, to explore mine applications for geocells in haul road, slope, channel, and containment pond solutions, and to learn how 3D geocellular confinement can produce higher performance and lower maintenance mine site solutions. We'll share a few case studies, and there will be time for questions at the end, so please enter them in the questions window. You can also provide feedback or additional questions through a follow-up email or by contacting us directly at prestogeo.com. For now, I will be muted. Thank you. The 3D GeoWeb cellular confinement system is perfect for mine industry solutions as it stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. Today's presentation will focus on permanent and economical solutions with the GeoWeb system for a number of challenges facing the mining industry. Stabilization of soft soils for access to site and haul roads, controlling and containing rainwater, protection of geomembranes in basins, tailings, and leach pads, and reclamations of slopes at the closure of a mine. Through 3D confinement and by strengthening the fill, less material is required and waste rock can be used on site. The GeoWeb system is our version of geocell technology and consists of two main attributes. The first is the cell size. The cells come in three diameters, small, medium, large, and varying cell depths. Cell sizes are selected following an evaluation of project-specific needs and site conditions. The ultrasonically welded seam, where all the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better their performance, the geocell. Stronger seams allow for heavier infill material, steeper and taller slopes, and better lifetime performance. GeoWeb is produced for consistently strong welds at cell junctions while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of a system is much more important. Here we see the typical GeoWeb panel as it comes tri-folded on a pallet. GeoWeb is lightweight and requires no specialized equipment for installation. Sections flex like an accordion so they can follow natural contours of the worksite without being confined to a rigid set of dimensions. The infill, or what you put into a container, is the second important attribute of the GeoWeb system. An important benefit of the system is that low-quality aggregates, sand, or on-site reclaimed material can be used to fill the geocells. Using reclaimed sand or aggregates can save a significant amount of money on materials and transportation costs. We can also remove fines if drainage is desired, as geocells provide the confinement and aid compaction of cohesionless soils. Without fines, we can significantly improve drainage and let water flow freely through the system, preventing poor pressure buildup and overall cross-section failure. This ability to use low-quality sands and aggregates with friction angles in the 20-degree range really sets GeoWeb apart from geogrids and geotextiles. Those planar products require high-quality materials with higher friction angles to achieve their optimal performance. With GeoWeb, materials with low friction angles are fine, and GeoWeb panels reach their full potential even with these poor materials, which can provide significant cost savings. As a value engineering option, the GeoWeb system can reduce the cross-section required by half. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. Therefore, an incremental improvement in one of the characteristics, like cell wall stiffness or ESCR, is only valuable if a complementary improvement has been made in the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin high-density polyethylene, and our proprietary formulation has stood the test of time for more than 40 years, containing no fillers, unstable polymer combinations, or exotic alloys. For most typical sites, GeoWeb will retain its durability for greater than 100 years, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind these numbers so you can deliver certainty in the solution as you build with quality materials you can trust. Additionally, GeoWeb and all of our products and accessories are 100% made in the USA under strict quality assurance and environmental control processes. Presto's GeoWeb system is equipped with numerous design and construction components that increase strength and speed of installation. Each of them with specific strength values so calculations and modeling replicate real-world forces, and the solution is designed for the project needs instead of as a commodity one-size-fits-all product. The system components are all the supporting pieces that help the GeoWeb protect the road surface and subbase layers, as well as slopes and channels, and also ensure relatively uniform performance of this interconnected system, thereby protecting against the damaging effects of non-uniform deformation and differential settlement in response to applied loading. The components make it safer, faster, and easier for installation. The Atra key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the slope or the area. It allows for faster installation of the GeoWeb and will last the lifetime of a project, ensuring that the GeoWeb system will not fail under anticipated loads. It will also ensure the system holds up to loading over time without the corrosion seen in staples or the failure of underperforming cable tie or two-piece systems. As slope angles increase, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage will be required. Atra anchors hold the GeoWeb to slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has an HDPE Atra speed stake designed to work with the GeoWeb and offer higher resistance to extraction than rebar or J-hooks. For steep slopes, a slope where native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, tendons can be used. The Atra tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the Atra tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together, so we go from problem to design to construction solution with a system where modeling replicates those real-world forces. Now let's talk about how to take advantage of the benefits of geocellular confinement. The first application we'll highlight is load support. The GeoWeb system stabilizes unstable soils vertically and horizontally, and in load support applications offers various benefits for mine clients. GeoWeb geocells were invented for supporting heavy loads over soft soils, the perfect solution for haul roads. Before giving specific examples with case studies, I'll explain how and why GeoWeb geocells work so well for load support. Again, GeoWeb was invented for solving a military problem, how to cross beaches with heavy military equipment. The Army sought a quick-to-deploy road solution, and a Presto engineer, Gary Bach, collaborated with Steve Webster of the Waterways Experiment Station to weld strips of polyethylene and form the first geocells. The system evolved to include UV stabilization and other improvements, such as perforation, texturization, and connections, but the concept of geocellular confinement and the particular strength properties of high-density polyethylene have been proven over 4 decades of load support. Likewise with the use of low-quality and low-friction angle infills. Here we can see the stresses of a subgrade with an unsupported subgrade on the left and GeoWeb reinforcement on the right. Notice how there's a complete elimination of the highest stresses at the surface with GeoWeb reinforcement. The stresses are reduced and distributed over a wider area, which we call the mattress effect. This mattress effect reduces stress reaching the subgrade and leads to a significant decrease in deflection and rutting. Let's get a bit deeper into how that works. GeoWeb geocells can alter the geometry of a soil pressure bulb beneath an applied load through the mattress effect. When a load is applied to a geocell reinforced layer, lateral earth pressures develop within the infill material, which is confined laterally by the geocell walls against movement, in turn developing upward shear resistance along wall interfaces throughout the interconnected network of cells. In essence, this lateral confinement converts horizontal earth pressures into upward resisting shear forces. When combined with suitable base reinforcement, such as an enhanced woven geotextile, it becomes possible to construct over very weak subgrade materials, including those with standard penetration resistance values less than 2 blows per foot, which is a CBR less than 0.5%. where most planar geosynthetic products such as geogrids would otherwise fail. GeoWeb's 3D system works in this way. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell and forms a stable system. The infill is limited in its movements, represented by the yellow arrows. The cells adjacent to the loaded cell provide that passive resistance, shown in the diagram by the red arrows. and the load is dispersed over a greater area in the lower layers as each cell helps support the ones around it. The GeoWeb cell walls also transfer hoop stress, which is important in keeping the system intact and helps create that mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the GeoCell system can improve load-bearing capacity. Strong seams, semiductal resin properties, and integrated connectors are critical to a well-performing system. The GeoWeb system and accessories are specifically designed to work together to be an effective permanent solution for soft soil locations. In a load support scenario, vertical deformation can only occur with either compression or compaction of the soils, or through lateral movement of soil particles. And by spreading out the load in a classic granular fill approach, you can reduce the compaction of the near surface soils. But only with cellular confinement can you assure there's no lateral shifting of those particles, which is what leads to rutting. The mattress effect also reduces stress reaching the subgrade, and by eliminating that lateral particle movement, the GeoWeb system can stabilize the surface, eliminating your need for constant maintenance. Here we see some of those impressive load support benefits with AASHTO H25 loading on a partially filled GeoWeb panel over soft subgrades. We see how the cells push back against each other to support the load, and that only the adjacent cell needs to be filled for that support. A great benefit to using GeoWeb is you don't need to have every cell completely filled before the road is usable, so you can reduce construction time and materials with this approach. GeoWeb provides a system with less rolling resistance, less required maintenance, less expenses needed for fuel, and less structure required to support your loads, all with better production, better cycle times, better operational costs, and better installation. A great value engineering solution for your site access and haul roads. The 3D structure functions well in remote areas where clean aggregate is scarce. Often at mine startup, that's also the case. The compact GeoWeb systems ship efficiently to job sites and require less trucks to transport materials. On-site sand infill in this example is used, so costly aggregates won't be necessary. Nearly any locally available granular fill, sand, or even waste rock could serve for the GeoWeb geocells in your projects. In the majority of cases, the GeoWeb system can reduce your cross-section depth by about 50%. GeoWeb allows stabilization with a reduced cross-section, ideal for underground haul roads. Let's look at a haul road example as a case study. Our case study for haul roads is for a mine site in South America and a great example of the power of geocells as a value engineering solution. GeoWeb geocells were incorporated into the design of a haul road at an active mine in Suriname, with heavy loading over soft subgrade and local scarcity of quality angular aggregates, as this was near their mine startup time. The prepared subgrade strength exhibited a California bearing ratio value of about 2.5%, consisting of saprolite and clay, with anticipated loading including CAT 785 haul trucks, so 275-ton vehicles, and a haul road useful design life of 10 years at 250 movements per day. GeoCells offered a value engineering design option with multiple benefits. The sticky clay soils made the road impassable with every hard rain, and adequate aggregate materials for a standard construction solution were not found anywhere nearby. GeoWeb GeoCells offered a great value engineering option with just one layer of 6-inch or 15-centimeter geocells, being able to support the heavy haul truck loading over soft subgrades and reduce the total thickness to 30 inches from the 60 inches suggested by standard design guidelines. GeoCells dramatically increase the shear resistance of the infill, which allows the use of lower quality fill to carry concentrated loads that would otherwise require crushed aggregate to prevent localized near surface shear failure. Here's that one layer of 6-inch geocells being installed. For an efficient and cost-effective solution. The infill was locally available coarse river sand known as small miners residue. And the GeoWeb haul roads function well. Even with hard tropical rains. The results of the GeoWeb installation offered notable benefits: a great reduction in the total cross-section needed, reducing it by 35% with coarse sand wear surface and by 50% with an aggregate wear surface. The estimated savings per kilometer are around $150,000 US. That's about $100,000 per mile in savings. Since installation, there's been a reduction in road maintenance costs of over 65%. There are no downtimes due to rains, and there have not been any deep ruts observed since installation, multiple years now. There's less vehicle maintenance and less fuel required, better productivity and operational costs, safer site conditions, and the expansion opened before the scheduled date and under budget. All in all, a very satisfied client. Project calculations included an analysis of bearing capacity improvement to evaluate the combined benefits of lateral confinement from the geocells in conjunction with the tension membrane effect of the underlying high-strength woven geotextile to confirm the proposed approach would meet design requirements. The analysis indicated the stabilized section would offer a substantial increase in the allowable bearing capacity over existing subgrade, without which it would only have an allowable bearing capacity of around 20 to 30 psi at best. An analysis of hoop stresses under working loads was also performed to verify the geocell system components would be able to withstand the demanding load requirements. Hoop stresses were compared to the ultimate tensile strength of the perforated cell wall, as well as the strengths of the internal and mechanical junctions. In the case of the junctions, ultimate strengths for all three primary modes of potential junction failure, shear, peel, and separation or splitting, were compared to the fully developed hoop stress under working loads to calculate factors of safety for each mode. For cell wall, the factor of safety against cell wall rupture was calculated. As shown, all the system components were verified to meet design requirements. I invite you to use our free preliminary design service to see how we can help save money and time for your mine site. With a little bit of design information, we can run calculations and determine the ideal solution to resolve your site's soil stabilization problems as a value engineering option or as part of your initial design recommendations. Visit prestogeo.com and see our free project design to get started. Our next application for GeoWeb will be slope protection. The GeoWeb system stabilizes unstable soils And in slope protection applications, that means we can control erosion while at the same time sustaining vegetation with steep slope angles. The GeoWeb system allows flexibility in a mine slope reclamation solution. And the GeoWeb system allows vegetation of tall, steep slopes, very steep slopes. GeoWeb also allows you to suspend a protective layer to vegetate or hard armor over geomembranes without the need to perforate the liner for anchors. And again, as you see here, able to sustain vegetation and control erosion in that protective layer. Here we have another example of the GeoWeb system with tendons over a geomembrane. The anchor system with ATRA tendon clips allows for a safe and strong installation without the need for anchor stakes or perforation. The ATRA tendon clips transfer loads from the geocell to the tendon and the tendon to crest anchorage. Here you see an example of that crest anchorage, a buried dead man. This case study is for a mine slope reclamation in Peru, with, as you see, some very steep slopes. The slopes and cut slopes had angles greater than 70 degrees, and as you see here, with much erosion. So a complete and complex solution was required, including the design and construction of integral rainwater channels with energy dissipators, all with the goal of managing stormwater and preventing slope erosion with little to no maintenance, as this was part of the mine slope reclamation in a closure phase. Long-term protection and a complete solution to control erosion, reclaim mine slopes, and control stormwater thanks to the GeoWeb system. And here on the far right, you see as vegetation is taking hold. Here's another look at the GeoWeb slope protection system from one of the world's largest nickel mine sites in New Caledonia in the South Pacific. The slope protection system included a staked GeoWeb slope using ATRA anchors, and the system has to stand up to extreme weather events, including cyclones with heavy rains, like 600 millimeters or 24 inches in 24 hours, and also strong earthquakes of magnitude 7 in the region. All this with 45-degree slopes. And here we see the infill placed using on-site waste rock from the mine, stabilized with GeoWeb geocells. We saw an introduction to GeoWeb channel protection in the previous section, and now we'll detail the GeoWeb mine channel protection system. So I've got a simplified diagram here to show how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components next. And I want to stress that when I say channel, I'm talking about protecting an area that can be the full width of the channel plus the side slopes. It can be just the bottom pane of the channel, or even just one or both side slopes like an embankment or dam structure. Full flexibility here for where you want to protect. The process for building up a channel protection goes something like this. To begin, we have our channel with standard dimensions and side slopes. Depending on the infill, a geotextile separation layer may be required. Then the GeoWeb panels are put in place. Note how the panels typically have crest anchorage at the top of the side slopes, as well as a horizontal turn. This is important for anchorage, but also to protect water from flowing under the panels. We have two options for anchoring. First is using Atra anchors or Atra speed stakes. These are placed along the face of the channel and at the crest. The second is to use tendons and a crest anchorage. So all the anchorage is at the crest and the side slopes or embankment, not along the channel face. The cells are then filled with desired infill material, and the GeoWeb system is designed to create a stable channel surface even when maximum flow velocities and shear stresses occur. The use of the 3D GeoWeb channel protection system is much more effective than two-dimensional solutions that are subject to scour. The fill material is confined within each flexible cell and protected against erosive forces, making the entire channel or embankment more stable. Two-dimensional solutions such as erosion control blankets or cementitious blankets do not protect the channel from the hydraulic forces of the water, so the channel can fail even with these 2D protection systems in place that are also prone to uplift. The GeoWeb channel system provides protection with a variety of anchorage and infill options to best suit your project needs. Here we see channels with vegetated infill, aggregates, and concrete. Cellular confinement improves the hydraulic performance of conventional channel protection materials. Presto has done extensive testing with the hydraulics lab at the University of Colorado State, and their lab has a static drop of over 80 meters or about 260 feet for nearly limitless flows through their lab flumes. The CSU test gave us formulas to calculate solutions for flows in vegetated GeoWeb channels up to about 9 meters per second or 30 feet per second. In aggregate channels, reducing rock size by 2 to 10 times compared to riprap or the Abbots and Johnson or U.S. Army Corps of Engineers methods, and in concrete channels with flows of more than 11 meters per second or over 36 feet per second, with the GeoWeb system surpassing the flow limits of the lab flumes. Vegetated channels are not typical solutions for mine installations, and aggregate channels are often used for mild slope installations like this example of an outfall channel for Rio Tinto. Or this example with shallow embankments in Arizona. The GeoWeb channel infill can be waste rock, what's readily available on site, and less costly than importing fill. For extreme flows and a permanent worry-free solution, concrete infill is recommended, as used in this spillway project in Peru. As well as in these remote site installations for San Andreas and Tyrone. There are many concrete GeoWeb channels at the Yanacocha mine. And traditional methods often open the possibility to failure points, in addition to longer construction times. If your mine site has differential settlement expected or seismic activity along the channel, An inflexible solution like these traditional methods should not be chosen. We're going to look at a case study for a high-flow mine channel in Guatemala. GeoWeb allowed for a resilient and fully armored, seamless channel without the need for expansion joints and the potential failure zones seen with traditional pore channels, all with a reduced cross-section. GeoWeb geocells can be incorporated to handle high-flow stormwater in remote locations, and their long-term resiliency makes them ideal for mine closure applications where environmental restrictions hold sites to consistent and permanent high performance, yet site access often allows only for occasional monitoring post-closure. Expanded durability standards are especially important with increased frequency of record storm events, and if either seismic activity or differential settlement is expected. As our case study will discuss, this mine site in Guatemala experienced record storm events and strong seismic activity, and the geosynthetically enhanced channel armoring delivered consistent performance that stood up to the challenge. Here are the design conditions and key components. The channel had anticipated hydraulic flow of 425 cubic feet per second, about 12 cubic meters per second. There were rapids included in the channel, and the client wanted to allow for excavator entry as needed for future cleanout. The mine site was originally considering an 8-inch or 20 centimeter reinforced poured concrete channel and looked to optimize design while maintaining a trapezoidal channel formation. Presto's design calculations supported a 4-inch or 10 centimeter geocell system to allow that excavator support, but the mine preferred a 6-inch depth for additional factor of safety. This was still 2 inches thinner than originally budgeted, so already offered considerable savings in concrete costs. The design included a non-woven geotextile as a separation layer, 6-inch geocells with polypropylene tendons and a load transfer system, and 4,000 psi concrete. The GeoWeb channel protection design incorporated our strong polypropylene tendons, ATRA key connectors, and ATRA tendon clip load transfer devices. First, the channel bottom was filled, then the side slopes working from top to bottom of slope. Note the yellow tendons and the deadman anchorage at the crest, as well as that horizontal turn at the crest that I talked about earlier. These anchorage components are determined project by project based on the details of your specific channel needs. Again, contact prestogeo.com for more information and to activate our free design services. Some step drop rapids were incorporated into this part of the channel design, with the GeoWeb geocells transitioning seamlessly into that structure. And here we see joining the rapids with the rest of the GeoWeb channel. And here's a drone view of the GeoWeb channel installation with the rapids here. The GeoWeb channel protection system allowed for a resilient and fully armored seamless channel without the need for expansion joints and the potential failure zones seen with traditional poured channels. The channel is now in its 4th year of performance without incident, even with record storm events and strong seismic activity in the area, with soil saturation, overflowing rivers, and landslides. Geocells with concrete infill have the long-term resilience and economy to be considered a best practice and are considered among the solutions with the highest long-term performance results from the U.S. Bureau of Reclamation's 10-year canal lining study. Here we see a comparison of allowable velocities and shear stresses for various channel lining alternatives from the U.S. Department of Agriculture. The GeoWeb system provides protection and flexibility, as shown in this mine closure channel in Mexico, using big riprap fixed in place with grout in a rockfall area. Or in these rapids in a Peruvian mine installation. All with various options for anchorage and installation, and various options for infill. All in all, a complete channel protection system for your project needs. Our design engineering team will gladly provide an evaluation for your mine channel and help provide a GeoWeb channel solution that satisfies all your project needs. Visit prestogeo.com to activate the team. Our final application today will be earth retention systems. The GeoWeb earth retention system can offer global stability and support of surcharges. Even with seismic activity and differential settlement. Retaining walls serve to contain soils and protect utilities or storage tanks, while offering global stability for very steep slopes, like this example in Central America. GeoWeb walls also function as containment dikes with or without vegetation, and unlike block walls, GeoWeb walls can withstand reasonable differential settlement, hydrostatic pressure, and seismic conditions. Our team of engineers can help with a retaining wall design, and we also offer free design software licensing. Visit prestogeo.com earth retention for more information. The GeoWeb system stabilizes unstable soils vertically and horizontally in the applications of load support, slope protection, channel armoring, and earth retention. GeoWeb offers improvements in operation, maintenance, installation, and safety, all at a lower total cost, giving your mine site powerful value engineering solutions. Part of our complete solution is our technical assistance. The engineering team here at Presto Geosystems works closely with project engineers and consultants, offering a free project evaluation service. The form is on our website, prestogeo.com, and you fill it out with as much information as you have, including attaching documents such as geotechnical reports, project site pics, or other info, and it comes directly to us. Then, within a few business days, our in-house design engineering team will provide a complete design evaluation, including infill recommendations and anchorage requirements. We'll work with you to get the best design for your project, whether it's a value engineering solution or the preliminary design work. We deliver quality and over 40 years of expertise. guaranteeing each shipment meets or exceeds our specifications so you can deliver certainty and build with materials you can trust. No disclaimers or concerning fine print. One of the biggest questions we get is about cost. No surprise there, especially if this is a new technology for you or your area. Having an idea of how much the GeoWeb system costs compared to other stabilization techniques is very important. Our case studies shared today hinted at cost savings. Here's another look with a basic comparison for GeoWeb in a load support application. In this case, a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. We see the GeoWeb system is both thinner and less expensive relatively than the other materials, significantly so when on-site materials are beneficially reutilized. In fact, a 40% savings can be realized compared to the geogrid and geotextile section, which does not allow for the use of most salvaged or on-site material, as high friction angle, well-graded materials are required for use with those type of geogrids and textiles. Of course, your aggregate costs, distance to quarry, etc. might vary, but this will give a general idea of the savings that can be achieved. Again, we're happy to run a value engineering design for you so that you can compare to other solutions accordingly. We've also made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars and PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand, so you won't find your certificate from today in there, but you'll receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. Then in 2 or 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand dashboard and other helpful resources. We'd also like to know what you thought of today's presentation and if we can assist you with any of your project needs. So if you do not receive either of the previously mentioned emails, please check your spam folder or contact us directly. Here are my contact details. Thank you for your time and interest in value engineering solutions for mine infrastructure with the GeoWeb system. You can see more case studies, installation guides, and videos on our webpage, prestogeo.com, as well as our YouTube channel. Be sure to join us in 2 weeks for the Installation Best Practices webinar, where you're sure to pick up a few technique tips and see great images showing the installation process for all of the major applications of the GeoWeb system. The Presto Geosystems team and I look forward to helping you with your next mine project. Thank you. Now we'll look at our questions and answer them in order received. If I don't get to your questions, again, please reach out to us, response to that follow-up email, or contact prestogeo.com at any time. A general email is info@prestogeo.com, or you may write to me, josepaulo.george@prestogeo.com. All right, so our first questions are in regard to the type of infill. One of them, the size of rock, and what size of fill rock do we recommend? So typically, that's one of the components of design that's taken into account for your project needs. As a general rule, we recommend up to 1/4 the cell depth size. So if you have an 8-inch geocell depth up to a 2-inch rock size. Again, if you have a specific idea in mind for your site, we're happy to have a look. Activate our design engineering team and we can run calculations accordingly, or just talk with us. The next is a comment. The tendons look rather labor intensive. Actually, for steep slopes, it's much easier and faster as well as safer. You can do most of the slope work and building that system on the flat crest part of the slope or even off-site. We have some great examples of that in our installation best practices webinar. So check back in 2 weeks or catch that one on demand and you'll see what I mean. You can build the entire system off slope. We have guides for the distance needed between each of those connections and then just hang it like a curtain over the slope. Very handy, especially with steep slopes or slopes that can't be punctured. Trying to put in anchors on a 1-to-1 or steeper slope is pretty cumbersome. So much less labor intensive than staking. The next question asks about compaction, and we typically recommend 95% Proctor. And there are multiple ways to confirm that. Again, you can see examples of that in our installation best practices webinar in a couple of weeks, but a quick answer, 95% Proctor. Also, you can see our design and installation resource package, or sorry, design and construction resource package on our website, prestogeo.com, that will have not only the installation guides and the quick guides, but a step-by-step video links as well. Next question, can you pave over top of it, over top of GeoWeb? Absolutely. We didn't give many examples of that, or any really, this time around. You can see more of that in our road solutions webinar, but yes, GeoWeb stabilizes those soils, and in a paved scenario, that stabilization is transferred up through the pavement. So you don't have those micro movements that cause the cracking of your pavement structure, and it will increase your pavement life by having that stabilization beneath the pavement layer. So it can be a rigid pavement like a reinforced concrete or a GRC, GeoWeb reinforced pavement, or it can be something semi-rigid or flexible pavements. It can be port pavements with paver blocks, many options. And again, you can see more resources like that on our website, prestogeo.com. But getting back to the question, yes, you can absolutely pave over the top of GeoWeb, and it will improve your total pavement structure and reduce your total cross section needed. Again, visit prestogeo.com, activate our design engineering team, and we're happy to run the calcs for you. Next question is specifically about the load support option, the haul road we mentioned, reducing the cross section from about 60 inches to about 30 inches. Those are actual values. But this question asks, where in the cross section is the geocell layer located? That is a great question, and I'm glad you asked. For optimal performance, you want the GeoWeb as high in the cross section as possible to reduce the stresses on the subgrade. That's how geocell technology works best, when it's high in the cross section. In this case, and in every case, you'll need some kind of wear surface over it. So allowing that wear surface, there was a high strength woven geotextile, a base layer, then the GeoWeb, then a wear surface atop that. So that's how that cross section worked. All right, next question. In wooded areas, raw material consists of wood mulch and pine needles. Can this be used to fill the GeoWeb for pickup trucks? Typically, that material is going to decompose over time and your infill will shrink away. So if it's a temporary, like very temporary access, maybe. But as the material decomposes, it'll disappear and you'll lose your infill, not through fault of the GeoWeb, but through that choice of organics. If you have something specific in mind or any geotech info, we're happy to run a scenario and look at that. But generally speaking, you want something granular. Next question, what is the design life of our product? In our calculations, we include useful design life, and often for roadways, it's 10 years, 20 years, 50 years, whatever the end client wishes it to be. I mentioned when I shared our product specification that it's often 100 years. We have lab testing indicating over 149 years without any degradation, even at full exposure. So the design life can be just about anything you like. It's going to outlive me and probably you, but we can allow for any of those numbers according to your design needs. Next question, how do GeoWeb cells hold up when they might become partially submerged or see water running over them? That's a great question. We didn't really mention them in this presentation, but in our paved and unpaved roads presentation, there's a great example of this in a low water crossing. So they work just fine is the short answer. They allow the water to flow freely through the system while still supporting the loading. And we have some examples of that on our website in case studies. If you search out low water crossings, or I'm happy to share that example as well. There are quite a few more questions, and I apologize if I didn't get to one of yours specifically. I'll take just one more, and then we have to close because we are already over time. Does it make a difference if the aggregate within the cells is sharp and hard angular like blast rock? So I'll answer that one, and then I'm afraid we must close. So the infill should be angular instead of rounded stone, and even if it's sharp angles like blast rock, that provides a better interlock in the cells than a rounded river stone, for example. So we will recommend that it's actually angular stone when possible. That gives you the best quality infill. But again, you can use anything granular, sand, on-site reclaimed material, etc. With that, I thank you for joining us. And again, please watch for that follow-up email from GoToWebinar with your PDH certificate, as well as the follow-up email from Presto Geosystems. Reach out to us at any time, info@prestogeo.com, or visiting our website, prestogeo.com. And we look forward to seeing you again. Thank you much. Take care. Bye.